Okay, it says if s of x equals 2x squared plus 3x minus 4 and t of x equals x plus 4, then s of x times t of x equals what? So they want you to multiply the two things. Well, even though they wrote s of x first and t of x second, when I multiply them together, I'm going to do t of x first and s of x second. Not that you have to, but I prefer when multiplying two polynomials to put the smaller of the two first. So I'm going to put the x plus 4 first and the 2x squared plus 3x minus 4 second. You don't have to do that, but I prefer to distribute from left to right instead of right to left. Now that you see it like that, do you know what to do from there? Okay, get busy. Okay, go. Okay, click the pin. The pin. You haven't clicked the pin. You're on the arrow. Okay, here we go. It doesn't matter. Right. I know. I think somebody hit the projector because see all the black at the top of the screen? That's why it's not calibrated. No, that goes under the 3x squared though, because okay, okay, plus, which is what choice? A. Okay. Is b squared minus 9 a binomial or a trinomial? A binomial. So you need to flip it over to the binomial side. The first question the flowchart says, is it a difference of two squares? Is b squared minus 9 a difference of two squares? Yes, it's definitely a difference. And then what makes something a perfect square? Right. If you can obtain this by multiplying something by itself, it's a perfect square. And you can do that because isn't v times v squared? And then 9 is also a perfect square because 3 times 3 is 9. Now, it also reminds you to use opposite signs. And the reason those are necessary is because 3 times negative 3 will make the negative 9. And because of everything being identical except for those signs, the middle cancels out. Because think about it. If you do the outer and the inner, won't the outer terms multiply to a negative 3v and the inner terms multiply to a positive 3v and they cancel out? And then the first terms multiply to v squared and the last terms multiply to negative 9. Okay, so that's how you do number 1. Those are the factors of v squared minus 9. Okay, let's look at number 2. Are we dealing with a binomial or a trinomial? A binomial. It's only two terms. Okay, the first term is that n squared. The second term is the minus 9n. Is this a difference of two squares? No. It is a difference, but both of those terms are not perfect squares. N squared is because n times n is n squared. 9 is a perfect square because 3 times 3 is 9. But just an n to the first power is not a perfect square. You can't multiply anything by itself and get n. Because think about it. N times n is n squared. There's nothing that you can multiply by itself and make just an n to the first, right? So we go down this route and we look for the GCF. How do we look for the GCF? No, that's for trinomials. For binomials, you list out the factors. Okay. Okay, and then 3 times 3 is times n. You don't have to worry about the sign. We'll just bring it down at the end. Now you circle what they have in common. What do they have in common? The n. What they have in common is their GCF. So you're going to factor it out. You're pulling it out of the binomial. And then in parentheses, you leave what remains after you've pulled out an n. From the n squared, only an n remained, because n times n is n squared. Bring down the minus. That's why you didn't have to worry about it over here. And from the 9n, what remained? 9. Because think about it. If you have a 9n and all you pull out is an n, doesn't the 9 remain? And so that's the answer. All right, number 3. Are we dealing with a binomial or trinomial? Trinomial. So this time we need to go, you don't have it? This time we need to go to the other side of the flow chart to where it says factoring trinomials. Okay, the first thing that we see is to the left, a equals 1. To the right, a does not equal 1. So for number 3, does a equal 1 or not? No. What is your a value for number 3? 3. Okay, so we have to go to the right. A does not equal 1. Is the a value of 3 a GCF? Can you divide it out of all 3 terms? Yes. You can divide it out of 3 and get 1x squared. You can divide it out of 6x and that'll make a positive 2x. And you can divide it out of negative 24 and that'll make a negative 8. Now, what that means is the 3 is a GCF, so you write it on the outside. You're factoring it out. You're undistributing it. Now, aren't we left with a basic trinomial with an a value of 1? And so that's where we do the bubble method. You look for 2 numbers that multiply to get your c, and they add to get the b. What is the c? Negative 8. And what is the b? 2. So what numbers multiply to get a negative 8 and add to get a positive 2? 4 and negative 2. So it'll be 3 on the outside. You have to continue bringing down the 3. And then an x plus 4 and an x minus 2. Now remember, the reason it's so important that you have that 3 on the outside is because look up at the board for a second. If this 3 was not there and you now distributed those two together, is x times x going to produce a 3x squared? No, but x times x will give you an x squared, and then when you distribute that 3 on the outside to it, you will get your 3x squared. That's why 3 has to be part of the answer. Okay, let's look at number 4. Is it a binomial or trinomial? It is also a trinomial, so we stay on this side of the flow chart for trinomials. The first thing that it asks on this side is if a equals 1 or does not equal 1. Which way do we go, left or right? Left. A does equal 1, so we use the bubble method. We look for 2 numbers that multiply to equal the c value, which in this one is 28, and they have to add to equal the b value, which is 11. Okay, so what 2 numbers multiply to a 28 and add to an 11? Right, a positive 4 and a positive 7, and then you're done. That one had no GCF. You just went straight to multiplying to get the c and adding to get the b. Okay, number 5. Is it a binomial or a trinomial? A binomial. So we need to go back to the other side. Okay, so number 5, the binomial is 9x squared minus 25y squared. Is that a difference of 2 squares? Yes. It's definitely a difference, and it's a difference of 2 squares because 9 is a perfect square. 3 times 3 is 9. X squared is a perfect square because x times x is x squared. 25 is because 5 times 5, and y squared is because y times y. So that is a difference of 2 squares. And look, all you're doing is taking the square root of each term. Like the square root of 9x squared is 3x, so you put that in both. And then the square root of 25y squared is 5y, so you put it in both. And then it also reminds you to put opposite signs because you need it to be a negative 25, and you need the middle to cancel out. Okay, number 6. Is it a binomial or a trinomial? It is a trinomial, so you need to go back to the other side. Okay, number 6. 5n squared plus 31n minus 28. The first thing it asks on this side is if a equals 1 or does not equal 1. It does not equal 1 because a is a 5. Is a the GCF? Can you divide all three of those terms by 5? No. Okay, so you go this route, which is what we learned yesterday. Multiply the a times the c and then use the bubble method. Well, a is 5, c is negative 28. What will that equal? Negative something. Okay, so that is now the number that you're trying to multiply to get. And you're still trying to add to get your b value, which is 31. Okay, so be trying to figure out those numbers. Okay, a 35 and a negative 4. Okay. Now what do we do? What does it tell you to do now? After you found the two numbers and multiplied, you divide them both by a, which is 5. And then look what it says to do. Remember to divide by a and reduce. What will this one reduce to? N plus 7. So you're done with it because it became a whole number. Will 4 over 5 reduce? So what does it say you do? It becomes the coefficient. That 5 on the bottom jumps out front and becomes the coefficient. And then you're done. See how the 5 jumped out in front and became the coefficient of x, or in this case n? And now look, it would work. N times 5n is 5n squared. 7 times negative 4 is negative 28. Negative 4n and 35n combine to 31n. It's not all multiple choice. There's a few free response. Okay, number 7, binomial or trinomial? Binomial. Okay, we have 3n squared plus 15n. Is this a difference of two squares? No, it's not a difference at all. So you definitely go no, and you look for the GCF. When it's a binomial, to look for the GCF, you just list out the terms and circle what they have in common. What are the factors of 3n squared? And then 3 times 5 times n. So they have a 3 in common, and they have an n in common. And that's their GCF, 3n. What was not factored out as the GCF remains on the inside, and that's what? Where'd you get a 9? N plus 5, right. And then that's the answer. Okay, number 8, binomial or trinomial? Trinomial. It has 3 terms. Okay, number 8 is 4k squared plus 68k plus 288. Okay, is the a equal to 1 or not equal to 1? Not equal. Is the a value a GCF? Does 4 look like it'll divide out of all 3 of those? Let's try. If you're not sure, you can just try. Okay, when you divide 4 from 4k squared, you're left with k squared. When you divide it from a positive 68k, you're left with, and when you divide it from a positive 288, you're left with, okay? So since it divided and everything came out to be a whole number, 4 is the GCF, so you factor it out. You're undistributing it from this trinomial. And that's what's left once it's undistributed, which is what factoring is. No, because now we have ourselves a trinomial with an a value of 1 that we can bubble method by looking for two numbers that multiply to give us and add to give us. And what numbers do that? 9 and 8. 9 times 8 is 72. 9 plus 8 is 17. And that's the answer. No, if there's a number out front bigger than 1 and you cannot divide it out of all 3, you do the method we learned yesterday where you have to do the a times c and then divide by a, all that. Okay, number 9, binomial or trinomial? Trinomial. We have x squared plus 2x plus 1. So for this trinomial, does your a value equal 1 or not equal 1? It equals. So we go this way where we use the bubble method. We immediately look for two numbers that multiply to get our c, which is, and add to get our b, which is, and the numbers that do that are 1 and 1. Now, the reason I put one on here that easy is because I want to show you what can happen on the test. We all know that the answer will be x plus 1 times x plus 1. But say that you're looking at all four choices and you do not see that. It may be because they wrote the answer like this, because they're the same. So you can just write it once and square it. No. Okay, number 10, binomial or trinomial? Binomial. Okay, we have 16x squared minus 9. Is it a difference of two squares? Yes, both of those terms are perfect squares, so you factor it into two binomials, just like it says, taking the square root of each term. What is the square root of 16x squared? 4x. And then so 4x times 4x will make 16x squared. What about the square root of 9? 3 and 3. And then it reminds you to use opposite signs because they've got to multiply to a negative 9, and the outer and the inner term need to cancel each other out. And then you're done. That's the answer. Okay, number 11, binomial or trinomial? Trinomial. Okay, so we have 9x squared minus 65x plus 14. Is the a value equal to 1 or not equal to 1? Not equal, so we go to the right. Is the a value a GCF? Definitely not. Even if you're not sure about 65, you should know 14 divided by 9 will not be a whole number. So you go down this route where it's not a GCF, what we learned yesterday. Multiply your a times your c, and what do you get? And then that's the number you're multiplying to get, and you're adding to get your b, which is negative 65. So go ahead and try to figure out those numbers. Give people time. You don't know how to find the two numbers? All you got to do is start doing 126 divided by 2, 126 divided by 3, divided by 4, divided by 5, until you see another number pop up that makes a 65. It is 63 times 2, 126. 63 times 2 is 126, and negative, but both negative. Yep, those are your numbers. So really, if you were using my method of just starting to divide, you should have got them right away. As soon as you did 126 divided by 2, so it's x minus 63, x minus 2. Or remember, it doesn't matter, you could have put the x minus 2 first. Now what do we do? What does it tell us to do over here? Divide by the a, which is 9. And then it tells you to reduce. This reduces to x minus 7. And then will 2 over 9 reduce? So what do you do when it won't reduce? You make this denominator the coefficient of x. So 9x minus 2. Okay, now number 12, binomial or trinomial? Binomial. Six n to the 8th power plus 3n to the 3rd. Is it a difference of two squares? Definitely not. It's not a difference at all. So it's definitely no, so we look for the GCF. How do we look for the GCF? You write out the factors. To get a 6 is a 2 times a 3, and then into the 8th is 3, 4, 5, 6, 7, 8. Now, the only way you would not have to write those out is if you can literally recognize in your head that there's going to be 8 ends and 3 ends. And so how many are going to get circled? 3. And there's going to be a 3 circled, so what's the GCF? Right. Now, uncircled will be a 2 and 5 ends, which is 2 into the 5th, and that makes sense because look, the 3 times 2 is 6, n cubed times n to the 5th is n to the 8th. And then look, there was nothing left uncircled here, so what do you fill it with? No. Think about it. 3n cubed times what would give you... No. 3n cubed times what would give you 3n cubed? 1. I know, but I wanted everybody to understand why. Okay, you are now going to work on the back by yourself until I say switch out.